Here we go. All right. Welcome, everybody, to today's webinar from Tecton, where we're going to talk to Nathan about they build real-time fraud detection systems over at Signifyd. Nathan, welcome to the webinar. Do you want to introduce yourself?
Thanks, Kevin. Great to be here. Thank you. So I'm Nathan Ackerman. I run the engineering team here at Signifyd. But before that, I did a couple of interesting jobs. I started my career at Microsoft, and I spent about 10 years there. And throughout my time at Microsoft, I worked in a variety of companies and products and technologies there. And I think a common theme was that a lot of them actually were powered by AI and ML, whether it was recommender systems in Bing or Xbox Live or search engine ranking and results. And then later in HoloLens, when I was working on hand tracking and object recognition, AI and ML was at the core of all of that. After that, I started a company called Owlcam, which was a 4G internet connected smart dash cam. And there were tons of scenarios where we were doing object recognition and had 911 crash response, again, powered by both AI and ML to detect that, in real time and at scale. After that, I was at Amazon and worked on a product called the Ring Car Cam and some other things. And then after all that, I ended up joining Signifyd.
Which one of all of those was the hardest engineering challenge?
That's a good question. I think they're all kind of different and unique, and I think that was kind of what was most interesting. The domains were really different, but what it allowed was to use kind of common background tools and tech that transferred. But I think when you go from a domain of object recognition to detecting, for example, when a car crashes, the domain and getting your head really wrapped around the domain and spending enough time on that piece really lets you have the insights to be able to kind of use the tools that you've learned how to use. But it's not just a straightforward, have tool can solve problem. I think that's actually a common misstep that I think a lot of people do. I think what's important is to really deeply understand your problem space, become an expert in it, and then you can utilize tools to get to an end solution.
And it sounds like all of these different opportunities perfectly set you up for what you're doing now at Signifyd. So maybe if you can just tell really briefly what led you to join Signifyd and what does the company do?
Yeah, so in terms of joining Signifyd, for me, it was really exciting because it was an opportunity to look at some of the tools and practices as a general set of technologies and really apply them to something that I think is pretty noble and innovative. I think, combining AI and next generation technology to really benefit society, I think is a really positive and it's a noble cause and something proud to be doing and something really worth doing. And so when we talk about Signifyd, Signifyd solves a bunch of problems for online merchants and brands, which is that they need to provide a wonderful customer experience in a variety of ways. And increasingly, they have to do more sophisticated things to make sure that everything from account creation to checkout to fulfillment to post returns and refunds can happen seamlessly, but yet they can be operated in a way that doesn't open up enterprises to abuse and other fraudulent types of activity. And so the way that we like to describe it is that we use our tools and technology to really empower fearless commerce. And so how do we do that? We certainly use machine learning. We use massive amounts of data to instantly decide whether an order or a return request is legitimate or it's fraudulent or it's abusive. And I think a key part of this here is, that we might talk about a bit today is, doing things at scale, and especially in a retail environment where you're dealing with customers, that it's fast enough and accurate enough, I think is a really big deal. I think, just to say kind of one more thing, Kevin, before you kind of come back, I think one of the things that is really, to me personally differentiating is that, we guarantee our decisions. And we're the only commerce protection provider that provides guarantees on all types of chargebacks, not just, payment fraud. We cover disputes over whether a package was even delivered or whether the right product was even in the right package or delivered, or whether the product was defective, when it showed up on your doorstep. And to be able to literally stand behind that from a guaranteed aspect, you've got to have, really strong AI and ML tech to back all that up.
Interesting. So do you guarantee the quality of all the decisions that your platform makes? Like,
I
what
think
if
that,
you
yeah, I mean, there's,
something is fraudulent and then it turns out to not be fraudulent, or vice versa?
yeah, I mean, the answer is pretty complicated. There's lots of different products, and we work with our customers. I think we're willing to have those conversations and stand behind our decisions fundamentally. And I think, you're only able to do that if you've got the tech to back it up.
Yeah, excellent. Okay. And so I suppose one of the use cases that you mentioned is transaction fraud, and that's where having fresh data really matters. Is that accurate? Like, it would be maybe interesting if we use that as one of the examples, and then look at where does ML apply generally? What are the common ML use cases? And I would also be curious there, and sorry for throwing multiple questions at you at once, that to what extent do you combine machine learning here actually with rules?
Yeah, so there's a lot there. Let's maybe start with the first part. So do you just mind kind of restating the first question, Kevin, and then we'll take these in order?
Yeah, what are the different main ML use cases? How would you segment those out?
Yeah, so we really use it. I'd say there's lots of opportunities throughout all of the development. I think it might be worth taking a step back for a second and talking about just kind of a little bit of a high level framework of how we think about the use case in general. But at a high level, we're taking in raw data, we're using that to create features. We're using features to increasingly be scored by models, and then we take scores and then effectively make a decision at the end. I think. And then the most important part that everyone forgets is the feedback loop, to go back to the beginning of, was that decision good, and kind of how did it do? And so I think at a macro level, the big example of a transaction would follow that flow. And then at the end, over time, you'd learn the quality of that decision. So, at a high level, the whole circle employs ML to optimize that over time. And the more data and the more transactions, the better and more capable you are. I think one of the strengths of Signifyd is, how long we've been doing this, and effectively how big our network size is. We've seen over 600 million global wallets, which is a big deal. And so whether or not an individual is trying to purchase something at a merchant store for the first time, there's a good chance that we've seen either that behavior or that before somewhere else, which is a huge kind of network effect. I think going back to the ML training aspect, like I said, in terms of optimizing the end-to-end, that's one of our use cases. But through also various parts of the process, each one of those are kind of discrete steps, and so they internally lend themselves to other types of optimizations. And so we have little microcosms of ML being applied to optimize and fine-tune areas, as well as kind of fine-tune and optimize the overall end-to-end flow of basically taking transactions in and a transaction stream of data, and then at scale, reliably, with low latency, making high quality decisions that we stand behind with a financial guarantee.
Did I understand that right? That you have multiple ML predictions that you're making in one sequence in order to make a final decision about a transaction? Yeah. Are there more examples that you could share there on?
Yeah. So I think there's lots of tools employed in the whole process here. And it's wrong to say that there's kind of one size fits all, but I think as an example, we have features that are models. And in that sense, where I think traditionally you might think of taking raw input and making a feature, having a model, having a score, and then a decision, that one pipe, there are many features of which that are their own models. And so they have their own kind of process for understanding their effectiveness and improving them individually. And so it's effectively a model of models in some cases. I think one specific example of that is, as we've learned over the year or over time, when you try and, for example, do a checkout or purchase something, increasingly a lot of the fields and text fields, not all text is equal. If you're purchasing something at home in your living room, you're probably going to put your real name and fill out things. And Kevin is a name that most people recognize as a name. QWERTY as an example, as a first name, I think a little bit less so. But gibberish detection and understanding what goes into these fields, if someone puts in literally what seems to look like random characters and letters, that's at least kind of intuitively, and of course we can talk about the data, but intuitively you'd think like, well, that seems like something's being hidden or something's being intentionally, obfuscated. And so, I think one example to kind of talk about this is around gibberish detection, where you can use that as an input feature. What's the level statistically of these fields being gibberish? How many fields are gibberish? How does the gibberish relate, over time and across different segments? And so, I think one of the interesting things around the business is, having these hypotheses, having these insights, and being able to rapidly test them to making a judgment as to whether or not ultimately you're improving your decisions.
And so did I hear that right? That basically you'd have a model that predicts whether some character sequence is gibberish, and it gives you then a confidence score and whether that's gibberish or not. And then that feeds as another input feature into the downstream model that then makes the final prediction as to whether this is likely a fraudulent transaction or not.
Yeah, I think that's a really good example. And there's kind of lots of those, but I think, as one such example, yes.
Got it. Okay, excellent. How quickly do you need to make these decisions, by the way?
Yeah, that's a really good question. I think the pithy answer is, as a consumer, you sitting at home, like when you click checkout, how long do you want to wait for that to say you're good to go? Increasingly, you want to be shorter and shorter and shorter. I think, as a customer, you want it to feel near instantaneous for you. And so when, and I think that's something that we absolutely want to support as an industry. We want to support, the merchants being able to provide excellent customer experience to the end, customers, and doing that in a way that mitigates risk and fights fraud. So, doing this at scale with low latency, it's critical, because that's really at the end of the day, when you or I are being consumers, that's what we want. It's that instant, transaction approved shipping. We effectively want it as soon as possible. And you've seen the whole e-commerce industry, I think, over time really shift, how do we make things more accessible? How do we make them faster? And without kind of going into names, I think we're really familiar with that trend.
Yeah. Does the same thing then also apply to the feature freshness, where you also need to have very fresh data? And if so, to the extent that you can give us any hard numbers or anything like that shows how important feature freshness is to you, that'd be really interesting. It's not too common.
Yeah, I think it's an interesting question. I think a lot of what you're trying to do, I think one of the areas that makes the industry that we're in with fraud detection difficult is it's a very adversarial environment. There are active people, some of which are increasingly very organized, trying to do aggressive amounts of harm with real intent. And we get up every day and try and stop that. And sometimes that looks like attacks in the form of high velocity, where they come and they try and hit things really hard and really fast. Sometimes it's in the exact opposite, where they try a low and slow burn. And I think you need to have technology and process and awareness of both types of situations. Certainly for things that are very rapid attacks and rapid trends. I mean, I don't think that anyone would argue against faster feedback in general. And so having tools that provide that's good. Having tools that provide up-to-date things, that's good. I think there's an old adage about your measure of unit, or your unit of measure is your a unit of error. And so I think it's just about kind of your perspective. If you're talking about features and feature freshness, when you're talking about time ranges that are milliseconds, you're having a milliseconds kind of focused business. When you're talking about seconds or minutes, you're having a minutes and seconds based business. And so I think increasingly you just want to be talking about shorter delays, because at the end of the day, the name of the game is making a high quality decision, as fast as possible, so that to the end, customer, it's near instant.
Yeah. Okay. So to summarize, you basically want to be able to make is fraudulent or is not fraudulent decision as quickly as possible, hopefully within just a couple of milliseconds. And you want to be able to incorporate data that is as fresh as maybe just a couple of milliseconds ago. what ML stack allows you to do that? What does yours look like?
Yeah, I think, the thing that we focus a lot on is how do we at speed get the end to end. And so we end up using a lot of different tools, and, so it's really about, how do we quickly, through monitoring and understanding and identification and people focusing on it, understand what's happening in the larger ecosystem, in small parts of the ecosystem. How do we understand it? How do we interpret it? How do we then experiment and go through kind of an end-to-end either feature development workflow or really like an optimization workflow of like what's happening. And I think just, cycle time on that is important. And I think having that mentality of how do we do that quickly end to end, and any tools that allow us to go through that process faster is an advantage.
Are there specific tools that you can mention that you have as part of kind of the toolkit at Signifyd?
Yeah, I think, we are talking today. I think, one of those is when I came to join Signifyd, one of the opportunities that I saw was, I think, to more and more treat the tools like tools, and the infrastructure like infrastructure. And I think, Tecton is one of those that allows us to experiment and have our ideas and take our insights and take all the massive amount of domain knowledge that we have and we've amassed and we build over time, and put it to work. And so, it allows us to really focus. With Tecton as a part of our stack, we're really focused on understanding trends, disrupting fraud rings, having increasingly faster fraud response, really being on top of the really rapidly changing landscape with, adversaries out there. And it lets us focus on that because, feature freshness is handled by, Tecton.
And are there other parts of the either your data stack or your ML stack that, I don't know, where you train your models or where you have your streaming events or data warehouses or anything else that you want to share here that you combined with Tecton to kind of accomplish your goal of rapidly developing these fraud detection applications?
Yeah, I think there's actually kind of a long list of this stuff. I think if people are really interested in it, I would encourage them, come join us, come work with us. We've got a lot of experience doing this. I think we're all very passionate about the space here. And I think it's probably a longer conversation, but one that we internally just love to have.
Excellent. A lot of people out there, especially the ones looking for jobs, are, of course, also very curious about embeddings, about LLMs, Gen AI, etc. Do any of those currently play a role at Signifyd?
Yeah, those are really good questions. I think it's all really reinforcing, like, it's hard to not say that, Gen AI and LLMs have just already been really transformative. I mean, it's really been kind of a moment for that, I think, and part of that is a lot of people are trying to figure out what to do with them and how to employ them. And I would also say that we see that from the fraud landscape too. When I talked previously about the gibberish detection, that's like old tech at this point, which is part of why it's an example that I think people can get their heads around. But, when you can go to LLMs and have them produce, increasingly compelling stuff that looks more and more real, I think you have to really think about, if gibberish detection is going to find real text all the time, then that's not the right thing to be kind of investing in. So I think, LLMs are going to be used adversarially against services like, ours and everyone's. And so I think if you're not really thinking about that from our side of the table, or, and if you're not trying to take advantage of the output of other LLMs, then I think you're at a real serious advantage. And so I think we're at a point where it's important to understand what's going on and to be thinking deeply about how those things can be used to detect and I think protect, and I think, as much as you can get ahead. So it's there's a lot of active interest in it, and understanding it. And so, considerable time spent there. I think embeddings is another really good example too. Different, but also important, absolutely. Taking kind of real world inputs and, getting semantic meaning and projection into like a different space so that you can compare things. I mean, absolutely. That's there are kind of a number of examples of that kind of today, and I think it's another one of the kind of concepts in the toolkit for us. I think it's a combination of a lot of different things that end up working.
Are there some examples where you're employing embeddings today where it's been most fruitful, whether it's like turning, I don't know, merchant data into embeddings, or transaction data, or buyer data, or all of the above? If there's any specific example that you could share, I'd be very curious.
Yeah, I mean, I think, it's in, I guess I'll kind of speak to it a little bit at a higher level if I can, just kind of given the kind of context of today. But, like exactly you said, understanding what people like, increasingly understanding what the intent behind transactions are, being able to group them, having transaction level data and being able to make really smart decisions based on that, and then being able to automate that with AI and ML at scale, like that meaningfully can move the needle. Again, but you need kind of the right analysis and expertise to understand, like, was that something, correct or not?
I want to go back to one other very interesting thing that you mentioned earlier in this conversation. You mentioned network effects, and you may see a certain user for the first time with a certain merchant, but maybe you've seen them beforehand elsewhere. Can you say a little bit more about how you employ network effects at Signifyd?
Yeah, so I think another example that I can try and make this a little bit clearer with is, proxies or VPNs. I think a lot of people shop online at home, and they do that on their devices, and they don't use a VPN, but it's kind of what I would say is kind of the vanilla experience of people are at home, they use their real name and address because they really kind of want the item. I think understanding if a request came via a proxy, like a VPN, is an interesting signal in some cases, because, mostly people don't kind of, before they go and shop online, quickly jump on a VPN and then go shop online. And so, for example, understanding that, but then again, if you're on kind of the fraud detection side and you start to see a lot of VPN traffic really quickly, like that seems less than normal, and maybe something's going on there. If you get, some transactions, maybe okay, maybe people are traveling, but if you start to see a lot of transactions over a VPN, that might be, suspicious. If that's happening in really bursty patterns, that seems suspicious. If it's happening in segments or in not segments, that also can seem suspicious. But the idea that you can take something from a concept of saying, hey, let's look at really how, proxies can and are being used, but then be able to slice that, in, for example, aggregation windows that are in short periods and longer periods, across segments, across merchants, across our entire network, or not, and being able to compare, for example, velocities in a short window, in a medium window, in a long window, in relationship to, larger distributional patterns. Like, all that becomes really interesting areas to explore and understand. And that kind of comes down to the workflow. And when, you have tools that allow you to do that faster, like, that's great. You can explore more, you can get to higher quality signals faster.
Interesting. With these patterns that you just described, are they typically always identified and picked up on by an ML model that is trained on seeing all these different patterns and then having seen historical fraudulent and non-fraudulent transactions? And so they learn, oh, there's spikiness in VPN traffic here, and that's typically correlated with fraud. So I've learned that as an ML model. Is that how it typically or always works? Or do you also have hand-engineered rules in the system where you'd say, if I see, I don't know, IPs from this ring or this specific pattern here, then always auto-reject?
Yeah, I think the problem with rules-based systems is that we see, a lot of the reason why our customers, merchants talk to us, is that rule-based systems, again, because of the adversarial network or the nature, the adversarial nature, they just kind of increasingly don't work. And so they come to us because that's not the technology we use. We do employ AI and ML, and we do that so that we can automate the decisions, so that they can be really fast, and that they can also be high quality. And so we use like you said, very similar to that. We are hypothesizing, back testing, and improving the models to identify this type of stuff. I think the goal all the time, and really the intent is, these are model-based decisions. I think there are some opportunities where they're kind of like business policies where I think there are some kind of specific cases, but the point here is to have next level technology to combat next level threats, and all that is founded in AI and ML.
Yeah. Given that these fraud attack behaviors change really quickly, does that mean that you have to train and retrain your model very frequently as well? And if so, like how frequently do you typically retrain your model, if you can share?
Yeah, I think it really kind of depends. I think it all comes down to understanding, model performance, and you do it. It's really understanding and having the right kind of monitoring set up so you understand what's happening and you're kind of able to react to it. And so, we do that, and that's precisely how we handle it.
Great. Okay. So maybe we can chat a bit more about the challenges of ML. And I'm curious, like, since you've joined Signifyd, if there is a little bit that you can share with us about the journey that ML has gone through at Signifyd, some of the challenges that you faced earlier that you don't face as much anymore today, and anything about the journey that you can share.
Yeah, I think challenges. I think, like I said earlier, I think a big opportunity was really treating the infrastructure more like infrastructure and letting us focus on the end-to-end workflow. And I think finding areas where we can do the end-to-end workflow faster, so we can, take that hypothesis we had in the morning and have a conclusion, that day, and then how do you kind of speed that up over time? I think really AI and ML is really in the backbone of what we do. We're absolutely in the decision-making process. And, like I described, we use it, pervasively. It's in our end-to-end products. It's in, optimizing the pieces of how we build the product. It's really everywhere. And I think being able to focus on the end result, that's really the key. And I think, one of the things that makes the challenge hard here for us is just it's a really kind of dynamic environment. And I think succeeding here is in understanding a lot of different domains. And kind of like I talked about really early on, it's not about just, can I train a model? It's about deeply understanding the fraud domain, the payments domain, understanding, yes, the technology, but the modeling space. And, I think fundamentally you're looking for these tiny patterns in these massive data sets. And, I think much to I think there's a perception that, there's a secret formula out there, which is big data plus question mark equals success. And like the machine's just going to figure it out. And, I think the reality is it's actually a lot of deep domain expertise and deep commitment to making that happen. Yes, using technology, but it's about really having the right domain understanding to know where to hunt, where to dig. It's not just like, oh, we fed it all the machine and then it just gave us the answer.
Yeah. And I heard you say just a minute ago that you're able to come up with hypotheses in the morning and then have a conclusion at the same day. How do you do that? Is it like mostly back testing, or do you throw like A/B test models out there as well and then see how they perform, and then you just throw it to production as soon as something has
yeah, I mean, that's what you want. You want to have a conversation in the morning, and then you want to know, as quickly as possible, what the next step is. And I think a lot of what we've talked about today is really that whole loop of, hypothesis, test, evaluation, refinement. It might get included in the model. It might then go in for further refinement. It might not work the first time. Often as an engineer, I'm sure you can appreciate that. But then, do you then try it again? And so it's all about that kind of cycle time and that velocity in that cycle time. I think depending on what we're talking about, back testing is a technology, A/B testing is a technology, like all these kind of can and are used, but it just kind of depends on what aspect you're kind of tuning and kind of working on. But I think again, for me, the perspective is in a really fast-paced industry where people are working, to literally fraud, or defraud, I think is the right word. but really attack other companies. Like, you need people who can quickly understand and quickly assess, hypothesize, and kind of turn the crank to combat that, and then also to get in front of it to detect it and stop it from happening in the first place.
Yeah. Are there any other best practices besides turning the crank as quickly as possible, as you just said, that you can share?
No, I mean, there are a ton. I think, look, if people are really interested in this, we have a massive network. And I think, for me, what's really been interesting is that the problems are always really, different. And there's always something new to kind of tackle. And it's just a really interesting space.
Yeah, it really is fascinating. Like you're solving a really important problem. It's a noble cause, as you just mentioned. And I love how you described that you're able to kind of detect these patterns across thousands of merchants, apply the network effects, and make decisions just within milliseconds to make the lives of these fraudsters harder or hopefully impossible at someday. So I really love it. Is there anything else that you want to share with the audience, throw out there, anything we didn't talk about already before we wrap up?
No, I think this has been a good overview. I guess thanks for having the time to come talk to us about this today, Kevin. I think we're all, very passionate about this space, and like you said, and like I've said, it's a noble cause. And I think it's a great example of using, technology, especially leading edge stuff, in an application that I think makes a real difference for merchants, and I think for kind of the betterment of society. I certainly want to live in a society with, who wants fraud around, right? Like, so, I think it's just a great opportunity for people, especially excited in the space around AI and ML, to have a tangible, like, really make a real difference application of it.
Yeah. And then my humble ask is please also stop full-on spam, especially spam phone calls. They just drive me crazy every single day. Excellent. Cool. Thank you so much, Nathan. Really enjoyed having you on here and giving us an overview over how you guys detect real-time fraud over at Signifyd. Thank you.
Thank you so much, Kevin.